next lesson, we'll continue on what we learned in the previous lesson on rational numbers, which, if you remember, are numbers that can be expressed as a fraction. So what we're going to do today is add and subtract like fractions, and what that means is fractions that have common denominators already. For this lesson, there's only one vocabulary word, a variable expression. A variable expression is an expression that contains both numbers and variables. Let's get started with the first of our 4 examples. Find the sum or the difference. Here what we have is a negative 6 over 17 plus a positive. So we have a negative 6/17 and a positive 9/17. Now the basic skill that we're covering here is something that is not new to you. This is something you learned probably as way back as 4th grade, adding numbers that have common denominators. So what we do is we right away fill in our denominator, 17. And now here's the part that's a little different. Here we have a negative 6 in the numerator and a positive 9. Remember, the rule of integers tell us that when we are combining a positive and a negative number, we subtract the 2 numbers, which gives us 3. And because the 9, which is the bigger looking number, is positive, our numerator is positive. So negative 6/17 and a positive 9/17 gives us a positive 3/17. Take a look at what we have here. 11 over 32 minus a negative 5 over 32. Now the most difficult part of this equation is having to work with these negative numbers. Here's what you have to remember. This negative symbol means the opposite of whatever is inside these parentheses. So what we have is a positive 11 over 32, and the opposite of a negative 5 over 32 is a positive 5 over 32. So what we do, we keep our denominator at 32. We add our numerators, 11 plus 5. That gives us 16. 16 over 32 can be simplified to 1/2. We'll be doing the same thing here. We'll be finding the sum or the difference. Only this time we have mixed numbers instead of just fractions that were less than 1. Again, this is all about recognizing the fact that these are separate terms, and you want to see that here what we have is a negative 3 2/7, and we have a negative 6 3/7. When both numbers are negative, we add the numbers and we keep the answer negative. A negative 3 and a negative 6 make a negative 9. 2/7 and 3/7 make 5/7. 5 and 7 are prime numbers that can't be simplified, so our final answer is a negative 9 and 5/7. Take a look at what we have at the bottom. Negative 4 and 1/5 plus 2 and 3/5. Now, we have a negative and a positive, which means that we have to subtract the numbers. And for something like this, there are 2 different ways that you can solve it. The first thing you have to do is to write your answers vertically. And you can see, I put the larger looking number at the top because we have to subtract them, since one is a negative and one is a positive. But we cannot subtract 1/5 from 3/5. So here's what I mean when I say that there are 2 different ways to solve this. One way is to take these fractions and make them improper. I want to remind myself of what the signs are. 4 1/5 becomes 21/5. 2 3/5 becomes 13/5. A negative 21/5 and a positive 13/5 gives us 8/5. Pardon me. Which gives us 1 and 3/5. Now there's another way to do this. Let's write our original problem. If these were numbers, always remind yourself of the signs. If these were numbers that were not fractions and you had a case in which one number in a place was less than the one below it, you would regroup, and you can regroup with mixed numbers too. When we see 4 and 1/5, we can look at this and take 1 away from it. If we took 1 away from 4, it would be 3. And then what we would need to do is express that 1 that we took from it as a fraction using the denominator that we have in the fraction part of our mixed number. So you see here, 3 and 5/5 is like saying 3 plus 1, which is 4. So what we would do is we would take this 5/5 and give it to the 1/5. So we're taking 1 away from the 4 and we're adding it to the 5/5, which would make this 3 and 6/5. And then this 2 and 3/5 would be the same. And we would subtract our fractions, 6/5 minus 3/5, or 3/5. And a -3 and a +2, that gives us a -1. These would be negative as well. So you see we end up with the same answer. Now, while I do recognize that this method is a little easier for numbers like this, where we are working with improper fractions, but if you have a situation in which your numbers are not just single-digit numbers in the mixed number, you might have 312 and 18/56, then using an improper fraction might not be as friendly. But at least here you have two methods, and as you can see, you would get the same answer either way. Now our third example is, well, just a repeat of what we've been doing, except that what we're doing, we have included variables. Here's why variable expressions is one of your vocabulary words. But the rules are the same. The denominator stays the same, so we have 15. The next step is the same as if we were just working with numbers. We add our numerators. 8x plus 4x gives us 12x. Now here's the piece that's different. When we're working with variable expressions, you know that we have numbers and variables. And in a fraction, there may need to be some simplifying to do, even when there's a variable expression in only the numerator or the denominator. You have to remember that these pieces are separate. This 12/15 is separate from the variable that we have. So let's take this 12/15 first in isolation. We see that the greatest common factor, or we know that the greatest common factor of 12 and 15 is 3. And so we divide. 12 divided by 3 is 4, and 15 divided by 3 is 5. This x in the numerator gets moved over to its same place in the numerator. And then that's our final answer. 12/15 x gets simplified to 4x over 5. And we'll do the same thing on the bottom. Here we have a positive 16 over 3y and a negative 28 over 3y, just as we've been doing all along. I'll right away put in our denominator. And now I'm going to solve for the numerator. A positive 16 and a negative 28 make a negative 12. So we have a negative 12 over 3y. Again, you want to remember that these coefficients are separate from the variable. The coefficients can be simplified. 3 is the greatest common factor of negative 12 and 3. 3 goes into negative 12, negative 4 times. 3 goes into 3 once. Since there's only one variable and it's here in the denominator, we move it over to its rightful place in the denominator. Now you can leave it like this if you want, negative 4 over 1y. I know that some of you still like to write in the number 1 as the coefficient, but you can simplify it further by writing negative 4 over y. Either of these is acceptable. And before we finish, we have one more example. Here we have a word problem. I've already done all the work. It took you 2 5/8 hours to paint the bathroom, and then you spent 4 3/8 hours to paint the kitchen. How much longer did it take for you to paint the kitchen? So this is just a basic subtraction problem where we are finding the difference between the two amounts of time that you spend painting the 2 rooms in your home. What we have is 4 3/8 minus 2 5/8. And what I did here, just to save a little bit of time, is I already solved and did it both ways. Here what I did was I regrouped. I changed 4 3/8. I took 1 away from the 4 and added it to the 3/8, giving us 3 11/8. And I subtracted the 2 5/8, giving me 1 6/8. This 6/8 needs to be simplified to 1 3/4 hours. Don't forget your unit. And then I also solved this by converting the mixed numbers to improper fractions. So 4 3/8 becomes 35/8 because 8 times 4 is 32, and then 32 plus 3 is 35. Remember, the denominator stays the same. And then the 2 5/8 becomes 21/8 because 8 times 2 is 16, and 16 plus 5 is 21. And once again, you can see when you do your subtraction, you ended up with 14 over 8, which simplified became 1 6/8, simplified to the end, 1 3/4 hours. So as you can see, both methods do get you to the same answer. You should use whichever one resonates best with you.